you have all 9 members of the crew here, and that includes the 7 of us who flew, plus the 2 backup payload specialists, Rick Chappell down there and Mike Lambton right here. So hopefully you're going to have an opportunity to hear from all of us today. What we want to do is hear your questions so that we can respond to them. You know, what we do at NASA today, we're divided into essentially 4 big organizations. One of the largest is the Science Mission Director, sort of symbolized here with the slide that shows you the 4 areas of our science endeavors: planetary science, astrophysics, heliophysics down on your lower right, and then the Earth science up at the top left. Those are the areas that we seek to study the world as it is today and help us understand how we can learn about other parts of our solar system and other parts of the universe that make life better here on Earth. Some of the exciting missions that are going on right now, I think everybody knows about Curiosity that's on Mars. Some of you may know about Juno. It's a satellite that's presently on its way to Jupiter. What makes it unusual is that it's powered by solar arrays. It doesn't have a nuclear power source the way that almost every other mission that has gone to deep space has had. We have new generation solar arrays that we think will actually be able to operate the satellite as far away as Jupiter, and it's doing very well so far. These are a couple of my favorite, this artist's concept of satellite twins called GRAIL. GRAIL were launched last year. They're satellites that follow each other around the moon, and their primary purpose is to determine the gravitational field of the moon. They also have the ability of actually giving us information about the moon all the way to its core. We had some elementary school kids who participated in a contest to name the satellites because we said, GRAIL's not too cool. So how about helping us come up with a name? And they came up with the nicknames of Ebb and Flow. So now my first question to all of you. How did we come up with the name of Ebb and Flow? Ebb and Flow, who knows? What's your name? Yeah, what's your name? Lula. How did we come up with the names Ebb and Flow? Anybody know? Think about it now. Okay, the moon. And what do we think the moon, what effect does the moon have on Earth? We think. Huh? Anybody like the ocean? What does it do? What?
Tidal waves.
The tidal waves. And what do the tides do? They come in and they go out. They ebb and flow. And so elementary school kids said, why don't we just call them Ebb and Flow? So that's how they became named Ebb and Flow. Right, Mike? Everybody knows Curiosity. Curiosity is presently, it's a car-sized rover that's now on the surface of Mars. Absolutely incredible accomplishment. It is not the first time that America has landed a rover on Mars. In fact, it's the 3rd or the 4th. But what makes Curiosity so unique is the way it got there. Up until now, we kind of landed a big beach ball, sort of like, with the rovers inside, and they bounced around, and very inaccurate in where they ended up. And we may land and end up a mile away, well, not a mile, but a long way away from the landing site. We wanted to be able to land Curiosity very precisely at the foot of a mountain in Gale Crater, and it was really important to be able to put it where we wanted it. And the device that was developed was called a sky crane. And so essentially what Curiosity did in its whole landing mechanism was to come into the very thin Martian atmosphere. We deployed a big parachute at supersonic speed, something that had not been done before. That initially decelerated it, and then we actually used rocket engines to slow it to a hover, for all intents and purposes, several meters above the Martian surface. And then with Sky Crane, a very simple crane device, cables, we lowered it to the surface of Mars. The cables were cut once it was sensed that Curiosity was safe on the deck, and then the Sky Crane flew away and landed in another area. I say landed, crashed in another area of the Martian surface, well away from Curiosity. It was very important because we didn't want Curiosity contaminated. Curiosity is the most advanced rover that we've ever put anywhere, however. If you look at the mast that's there with the camera, it's a set of 2 cameras. One is There are two monocular cameras, one for distance vision, one for close-up vision, and we're going to use it to give us high-definition color, three-dimensional images from the surface of Mars. It also has a number of cameras on the rover itself, and this is actually from one of Curiosity's navigation cameras, one that sits pretty low on the body of the rover. So this is a real picture of Curiosity on Mars, whereas the other one was an artist concept. The next big directorate is the Human Exploration and Operations Mission Directorate. They're responsible for the conduct of the International Space Station. They used to control the space shuttle when we were still flying shuttle. This is where you would find our efforts right now in developing a commercial crew business for the United States. We already have one company, SpaceX, that is scheduled to fly our first for-hire cargo flight coming up the 7th of October. Another company called Orbital Sciences is in their development process. Will go through the certification of their system. Their module for cargo is actually called Cygnus, and it represents an international venture because Cygnus is actually produced by the Italians. The rockets that they use are Russian, so it's an international enterprise when you really look at it. They also handle, by the way, all of our satellite communications. So Human Exploration Operations actually controls all the satellites that NASA owns and operates, mostly for communications. This is an image of the International Space Station. One of us is unique in the crew. See Michael Fold, Colin?
We are all unique, John.
Well, yeah, we're all unique, but he's really unique. Mike is the only one of the crew who's actually lived on the International Space Station and also has lived on Mir. So he has spent a portion of his life both in the Soviet space station, no longer, Mir, and in the International Space Station, which is there today. And he's going to talk a little bit more about that later. These are some of the commercially available carriers now. SpaceX Dragon on the left, and you can see it's actually charred. This was the first one that they flew on a test flight back in December of 2011. Then in the middle is Orbital's Cygnus, and on the right is NASA's heavy lift launch vehicle. We presently call it the SLS. It's searching for a name, and we'll come up with one of these days. 3 lessons for all of you, and then I'm going to sit down and let the crew talk. You know, we didn't get here by accident. We got into the astronaut office by various means. Some people, like me, never dreamed of being an astronaut, never. And kind of met somebody who inspired me and kind of embarrassed me into applying for the space program. But I think most of my crew members, that was a lifetime dream for them. They knew what they were going to have to do. They knew they were going to have to study. And so that's the first lesson we have for you. I know it's basic, and I know you probably don't want to hear it. You want to be entertained. But we're also here to try to be serious a little bit. And you've got to study. And you may ask me, what do you need to study to be an astronaut? Everything. Everything. Particularly math and science, because those are just integral to everything that you will want to do. And it doesn't make any difference that you may not want to be an astronaut. You really need to understand the basics of math and science. So study really hard. I show you airplanes because the third big part of NASA is the aeronautics mission directorate. And in aeronautics, we help develop airplanes, aircraft systems, but also the transportation system, the radars, and the way that we get airplanes across the country and now around the world, working on something we call NextGen that's going to revolutionize the way that airplanes get through the air. This is an original NASA kind of a hybrid research vehicle that has developed today into an operational aircraft